YouTube viewers. In this particular video, what we're going to talk about is the central limit theorem. So the central limit theorem states that the sampling distribution of the sample mean will be approximately normally distributed regardless of the population's distribution given a sufficiently large sample size. This theorem is fundamental in estimation because it justifies the use of normal probability models of inference. So we're going to come over here to the beginning of the page. So it's the central limit theorem. So it's 1,000 inputs, which is 1,000 rows of data, and 30 samples. So basically, row A is an exponent. So that means it's an exponential distribution with a random number with a mean of 5, and false means it's a PDF. And then we're going to have 30 samples. And then so it's going to be index $A$3 $$3 to $$A$1002, and it's going to be a random number between 1 and 1,000. And so what that does is that indexes, it samples these values here, and this is 1,000, and it's an exponential distribution, and this is sample number 1, and you go all the way for 1,000 times. So you go all the way to sample to the end, sample number 30, and then you get the means, which is the average of B3 to AF3. So that's the means. And then what you do is you create a histogram of the means. And you can see here the histogram is very nearly normally distributed. And so if you expanded upon the samples, making it 50 samples or 100 samples, it would be more closely normally distributed as well. But you can see that's a pretty good normal distribution. And then we have a Pareto chart. Again, what the Pareto chart does is it gives you like a value counts what you would have in Python. So the highest frequency of values is going to be on the far left going all the way down. And so we've got the Pareto chart there. And then we have our exponential distribution. So you can see that this is what the exponential distribution looks like. So this proves the central limit theorem. So that's your histogram of your means, which proves that even with an exponential distribution, if it is sampled enough times, then it's going to be approaching a normal distribution. So that concludes this video. The next video is going to be about confidence intervals, and I hope that you decide to watch it.